Hello everyone, I'm Planet and I'm making free videos that teach quality engineering step by step so you can build real skills without paying any free or without paying expensive courses. So let's start. So welcome back again. So our last sessions we covered about the philosophies and the pioneers behind the quality as a discipline. So today we're going to go on a deeper level in the quality management system, the QMS. And specifically, this is in the chapter one for Certified Quality Engineer Handbook from ASQ. Let's say, for example, how organizations plan strategically for quality, how they deploy that strategy through a concrete techniques, and how they build information systems that keep the whole thing running. So here's the roadmap. First is the strategic planning or the SWOT analysis, the 10 effectiveness test for a strategic plan and SMART goals. Second is the deployment techniques like the benchmarking, the stakeholder analysis, the performance measure, and the balanced scorecard, the cost benefit analysis, and the full toolkit of project management like the decision trees, the WS, the Gantt charts, the RACI matrices. So we'll also cover a policy deployment here, and finally we'll spend a real time on the quality system, quality information system or the QIS, what it is, and the PLC and the SCADA or SCADA systems that run on the factory floor, the tools used to design these systems, and a real case study of a packaging plant in Texas that turned into operation using the exactly this kind of system. So this is the management and leadership heavy chapter. So expect less statistics and more organization tools. So, but these are the tools as a quality engineer actually use day to day to get initiative approved, funded, and executed. So strategic planning for quality begins the same way most strategic planning does. So with an analysis phase, most commonly as the SWOT analysis, the strengths, weaknesses, opportunities, and threats. So let's walk through each quadrant the way the chapter frames it. So strengths are the organization existing advantages. They should be leveraged deliberately to create a sustained competitive edge in a market. Weaknesses are the gaps that should be addressed head on, often through a training initiatives to build up strategic skills or through a dedicated process improvement efforts. Opportunities are identified through marketing research, things like estimating the size and the growth rate of the market, and clearly articulating what customers actually expect, desire, and perceive. So that research should directly feed the new product development. So threats require assessing the business environment, and this chapter is specific about where threats come from, like the direct competitors offering similar products, indirect competitors offering substitute products. So the book is, the book's example is butter versus the example will be like the butter versus margarine. So suppliers of critical proprietary components who could squeeze you, and even distributors who are influence the final customer's purchase decision. So the key principle here is strategic planning for quality should ideally address every one of these four elements. So not just comfortably once. And once this SWOT analysis is complete, the organization is ready to develop its actual strategic quality plans. So which bring us how you test whether those plans are any good. So once a strategy is drafted, management needs a disciplined way to check whether it's actually going to work. And the chapter gives us 10, sequential effectiveness tests shown here as figure, or shown as here in on the screen. So let me walk you through each one and add one color from the text. So one is, does the plan address the four SWOT elements comprehensively, not just the factory floor, but finance, purchasing, HR, marketing, sales, delivery, and the customer service too. The old idea that quality improvement is confined to the shop floor is described by the book obsoletely. Two, will it create a significant competitive advantage and will the customer actually notice and value it? So a superior product that nobody knows about doesn't help, and marketing has to raise awareness. Three is that advantage sustainable or can competitors copy it quickly? So the book specifically warns against competing on cost reduction alone. because price is the easiest thing to rival, to imitate, and a price war benefits no one. So pursuing an outstanding quality through a continuous improvement, the Six Sigma model is a much more durable strategy. Four, does the vision genuinely inspire and motivate employees? Not so difficult that people give up, not so easy that competitors also, leapfrog you. Five, are the goals and objectives smart? Well, we'll expand that on the next slide. Six, are the goals aligned throughout the organization without conflicting priorities as they cascade down? Seven, are resources, staffing, equipment, financing generally adequate? Eight, are the organizational, structures and processes suitable for executing the plan, or does something need to be reorganized? Nine, is there a review and reporting system with clear milestones, ideally supported by simple checklists? And then, does the planning team include experienced people from every effective group? The book specifically cites the Ford's advanced quality planning process, which lists the cross-functional teams as its number one expectation. So SMART gets its own moment because it's referenced constantly throughout the chapter one, in strategic planning, in performance measure, and in project objective. So S is specific. We can state exactly what's expected in precise terms. Vague goals like improve quality don't count. So M is measurable. Progress has to be demonstrated through a quantitative measures, not subjective impressions. So you need a number you can track over time. A is achievable. The goal has to be reachable and with the resources available provided the right actions are taken. So this is about realism and capability, not just ambition. R, is it realistic? A reasonable, sensible person, after weighing the difficulty and the probability of success, would actually accept the goal as doable. Note that is subtly different from from achievable. Realistic is whether it's sensible given everything is going on, not just whether the resources technically exist. Okay, and T is time-based. Deadlines serve a real purpose, and the book makes a specific point here. Like companies that are first to market within innovation frequently enjoy a significantly sustainable advantage over competitors. So a goal without a deadline isn't really strategic goal at all. So once your goals and objective pass the SMART test, the next challenge is cascading them down through the organization. Things people that they actually act on, which is exactly we will look at next. So this slide walks you through the example work from the chapter, like showing how a single strategy cascades all the way down to a concrete action plan. It's worth reading through in order because each level gets progressively more specific. At the top, the organizational strategy is broad and aspirational. Continually build, retain a loyal customer base, and on its own nobody can act that directly, so it gets translated into a organizational goal: deliver all products to all customers 100% on time. Still fairly broad but now measurable in principle. That goal becomes an organizational evidence, and this is where smart really shows up. Improve delivery dates of all future customers orders from 35% to 75% on time delivery by February of the current year, and to 100% by August. So notice how specific, measurable, and time-based that is. That objective then cascades to a functional objectives owned by a specific department. The quality department will assign a quality engineer to convene a cross-functional process improvement team by November 1. And that team will use lean manufacturing techniques to reduce cycle time until 100% achieved on time delivery on time delivery. So, and finally, action plans translate all of that into a detailed mini project plan style documents stating exactly how and when the objectives will be achieved and by whom. The point of walking through this cascade is that goals alone are never enough. They have to be supported by measurable objectives, which are in turn by supported by action plans and all the way to individual accountability. Benchmarking is the process of comparing your organization performance against your competition or against the best practices found internally or outside organization. It's worth mentioning it was pioneered by Xerox in the late 1970s under the competitive pressure in the photocopy industry, and it's now considered a core input through strategic planning. There are four distinct flavors, and it's important to know that the difference. Internal benchmarkings compares performance between different plants or divisions inside your own company. It's the fastest to execute and a good place to start because early wins here build credibility with skeptics before you attempt anything harder. Competitive benchmarking assesses your performance directly against competitors in your industry. The book example in ASQ Certified Quality Engineer Handbook is the automotive manufacturing is using a customer surveys to compare quality and satisfaction. Both internal and competitive benchmarking are useful for identifying performance gap. But here's an important limitation for that chapter. Uh, Competitive benchmarking may not actually identify the best practice needed to close the gap. It tells you um, where you stand, not necessarily how you fixed it. Collaborative benchmarking requires two or more organizations to cooperate, each freely sharing best practice information in exchange for the partner's insights. So the book example is a hypothetical partnership between Walmart and Dell. So one sharing demand forecasting, the other sharing order to delivery efficiency. The key with this type is identifying the very best performer and using trade associations, publications, or market research to find that leader. External benchmarking broadly may uncover the best opportunities for improvement, but there's a cat on my face. But it comes at the highest cost in time and effort, which is exactly why the chapter recommends doing an internal benchmarking first to build organization muscle and experience before pursuing external partners. So one important caution to leave people with, benchmarking is not a precise discipline, and real leadership means not just catching up to industry leaders but surpassing them, something benchmarking by itself can never accomplish. So once you decided to benchmark, the chapter lays out a typical project structure in four phases. And it's worth walking through what actually happens at each stage. So planning, identify precisely what is to be benchmarked and set clear study objectives. The chapter gives us a useful warning here. If the scope is too narrow, the benefits will be limited. If it's too broad, the task becomes unmanageable and you're less likely to successfully implement whatever you find. So these phases also include selecting your team and searching for target organizations. So data collection. So we need to develop a mutually acceptable protocol with your benchmarking partner and including a code of conduct, confidentiality agreements, exact which performance measure will be analyzed. So data sharing might cover procedures, standards, software, or training systems. So the goal is gaining enough understanding to actually replicate the best practice back, sorry, in your own organization. Analysis. So assess the data for accuracy and credibility, determine your current performance level, and identify the gaps. Critically, also explore whether the practice is even transferable. Like some practices need adaptation before they work in a different context. And forecast the expected improvement. Implementation, the fourth step. Obtain from key stakeholders, apply project management techniques and action plans to actually initiate the change, uh, monitor the performance as it rolls out, and document activities and communicate progress throughout. So common pitfalls across fall or these four phases include lack of commitment, insufficient planning, comparing processes that are not similar enough to generate useful insight, and benchmarking process that don't have much potential for meaningful gains in the first place. So every policy has to be evaluated against the needs of its stakeholders. And this chapter identifies five distinct groups. So let's go each one and what it looks like about the book. The stockholders. So that firstly is the stockholders. So the owners of the company, their role is often described as the passive and their needs are primarily financial. So they expect the company to maintain its credibility in financial markets and hope for growth in earnings and share price. The executive group, the board of directors and the top tier managers must acknowledge and actively serve the other stakeholders groups. The health of their whole organization is critically dependent on their decision making and how well they deploy strategy. Employees other than top management are described as the critical group with little direct impact on the policy itself. But every other stakeholder group depends entirely on them to carry out what policy efficiently and promptly. The quality of the end product depends on how well these employees are recruited, trained, and supervised. Suppliers and customers are grouped together because they represented external inputs and outputs. Suppliers must meet contractual requirements and in exchange can insist on fair and prompt payment. Customers, though, are described as the paramount stakeholder. If customers stop wanting what the organization produces, the organization eventually ceases to exist, like full stop. And finally, the community at large. So neighbors, environmental regulators, law enforcement, chambers, and commerce and legislators. Individually, their impact on day-to-day operation is relatively slight. But if a major issue arises, the book specifically mentions about plant openings or closing, treatment of minorities or environmental concern. Community concern can have an overwhelming influence on the organization. So the overarching principle is policies and their outcomes must be periodically audited for congruence and if adaptation is even needed. So it must stay within the original intent of the policy or it loses the credibility with these stakeholders. So once the strategic plan is finalized, the management needs metrics to monitor activity and track progress. But before we talk about specific numbers, it's worth stressing a point this chapter makes explicitly. Metrics must reflect the strategic vision. Some authors call it as a leakage, and there's a simple test for it. An organization is on the right path if people two or three levels down from top management can clearly articulate how their own day-to-day activities support a strategic objective. The chapter lists four qualities every good performance measure should have. It should be linked to strategic objectives, not just because it's easy to measure. It should be rigorous, objective, quantifiable, and standardized. It should be achievable, realistic, and time-based, like SMART again. So it should be assigned to specific accountable personnel who are actually empowered to enough uh, control to influence the outcome. So there's no point holding someone accountable for a number they can't actually move. So one subtlety worth explaining, the chapter wants you to select measures that are resistant to problematic behavior. Its example is the maintenance department that under pressure to cut costs, postpone equipment overhauls, so helping the short-term cost number while quietly setting up a future catastrophe. So the book proposed a fix proposed fix like is a combined metric maintenance productivity calculated as the ratio of change in the mean time to failure divided by the product of the change in maintenance budget and change in the mean to repair. So the trick is that when this metric is normalized to one, when nothing changes period over time, above one means improving, so below one means deteriorating, and because spending it's in the denominator alongside repair time, gaming the budget alone won't help. So if you cut spending and reliability suffers, the metric catches it. So then there's the balanced scorecard introduced by Robert Kaplan and David Norton in 1992. So their core argument was that most strategic plans were unbalanced because they overemphasized just one stakeholder group, the stockholders. Their fix was poor perspective shown here, like the financial fundamentals like cash flow, sales, and ROI. So business processes like yield, rework, and order processing, the customer perspective covering satisfaction trends and service wait times, and the learning and growth. The human element, participation in suggestion programs and training. So in a typical scorecard, each objective is listed with its associated measures, performance targets, and initiatives that will actually drive the organization toward it. So cost benefit analysis or the CBA estimates the strengths and weaknesses of alternative courses of action to determine the best use of investment. Comparing the total expended cost against the total expected benefit, usually expressed in today's dollars. So let's walk through the three main financial methods the chapter covers. So using the work example from the text, a quality engineer deciding how a fixed wearing out production machine that currently is scraping about 1% of production. First is payback period, simply the number of years it takes to recover your investment from net cash flows. It's widely used because it's easy to calculate and simple for non-financial people to understand. In the book, decision tree example, replacing the machine has a payback period of under 1 year, implying a very high return. But payback has a real weakness. It tells you nothing about the size of savings after the investment has already been recovered. So two options with the same payback period could have very different long-term value. Second, the net present value or the NPV. This fixes the weakness by accounting for the time value of money. You find the present value of each year's cash flow, discounting at your organization cost of capital, typically around 10%. Sum them all up, and if the total NPV is candidate for approval, in the work example, the new machine option shows an expected value of $125,000 against initial investment of 110,000 for a first year net return of just 15,000. So that sounds modest, but when you project that cash flow over the life of the investment using NPV, the true value comes out 37, no, 279 $136. So that's the power of NPV. It reveals the value that the simple first year snapshots completely hides. Third, third is the internal rate of return or the IRR. So the discount rate at which NPV equals exactly zero. So if a project's IRR is greater than the minimum rate the organization requires for typical capital investment, sometimes called a hurdle rate, often 10 to 20%, the project clears the bar for consideration. So one reason companies set a high hurdle rate, even higher than they could reliably earn or on stocks or bonds, is the inherently difficult of getting accurate estimates of a future cash flow. It is a built-in safety margin. And if a final word of caution for this chapter is always run a sensitivity analysis, checking how much NPV would change if your assumptions probability of success, future cash flows turn out to be optimistic by even 10% of the data. Okay, so the chapter lays out 16 detailed projects sequences usually captured in a project charter. So rather than reading all 16 verbatim, I've grouped them into 5 practical phases. So which all expand on now with real detail from the text. So define. So this starts with a clear problem statement, translating the kernel of an idea into a precise statement of the problem. So deficiency or opportunity, which helps clarify scope later. Next comes with the project justification, running the risk analysis we just discussed, like the payback period, the NPV, the IRR, the ROI, or return to assets. My nose is itchy, benefit cost. So leading to a go or no go decisions. Then drafts, the mission statement, project scope, and objectives are written to clarify overall direction. Organize. So stakeholder requirements are identified. The book distinguishes two groups here. Those with a direct commitment to the team, like a process manager lending a skilled person, and those without direct involvement, who can still influence results, like a purchasing department, like selecting a vendor. Um, then the project team itself is formed, ideally matched on not just on skill but on interpersonal fit. The book actually referenced the Myers-Briggs type indicator as a useful tool for building complementary teams. So the mission, scope, objectives, and charter are then finalized, explicitly naming what's out of scope to prevent scope creep. So next is plan. Contractual requirements and deliverables are documented. The work breakdown structure, or the WS, breaks the project down hierarchically into a task level detail. So we'll look at the real example next slide. Gantt chart lays out a timeline for example, for more complex or shorter term projects, an activity network diagram may map task dependencies. A resource requirements matrix details personnel, facilities, equipment, and cost by type and timing, and for our larger products, a linear responsibility matrix, or its common modern form of RACI matrix, defines who, what responsibility resource, who was the responsibility. Next is the resource. A detailed itemized project budget is prepared based on the team's time and cost estimates, and specific quantifiable measurements are defined to track both progress and achievements of objectives, including how corrective actions will will be triggered. And finally, the approve, the final sign off and authorization to actually implement the plan. One important practical note from the chapter is work review meetings should happen at least monthly for any objective spanning more than 3 months, plus every major milestone. And reviews should never be delayed until right before the plan completion date. Okay, so let's go deeper on the three project tools shown on the screen. So since my notes are really itchy. Since these are ones quality engineer use constantly in practice, the work breakdown structure or the WS allows you to determine many activities that must occur during a project by breaking the work down into a hierarchy, families of like work clustered down to task level. The chapter on example is generally useful, like a full ISO 9001 QMS in implementation project, broken into major branches like quality system documentation, training, quality system implementation, and controls, each of each of which is further broken down broken down. Like for instance, training splits into ISO 9001 briefings, steering committee meetings, management representation training, internal auditor training, audit behavior training, and statistical process control training. So the numbering scheme with the multiple decimal points looks at complex at first, but it allows nesting at levels in which it much easier to manage changes as the project evolves. Sorry. The Gantt chart, one of the earliest planning for and spanning in the existence dating back to the early 20th century. So list major back project steps or task clusters vertically against a timeline. So typically in a weeks, months, or quarters. So solid bar shows the estimated start to finish duration of each task, while the triangles mark specific milestone events. So as the project progresses, the same chart can be updated to plot actual time expended right next to the original statement, which makes schedule slippage immediately visible. So the book's own example covers an 18-month ISO 9001 implementation project, all the way from selecting a consultant through a final registration. And the RACI, or Responsible Accountable Consultant Inform, um, responsible people actually do their work to complete a task, and there can be more than one. Accountable is the person answerable to the task being completed correctly, critically, and there can only be one accountable person per task, which prevents diffusion of ownership. Consulted are people whose opinions are actively sought before decisions are made. Informed are people kept up to date, often champions or leadership who needs visibility but aren't doing the work themselves. So the book own example are RACI chart walks a product through a defining specifications, defining project scope, building a prototype, testing it, and coordinating approvals, and finally designing approval and release. So with marketing, project management, engineering, and QA each taking different RAC or I roles at each stage. So policies are different from strategies or goals. So they provide direction to guide present and future decisions, indicating that the principle to be followed or what is to be done, but deliberately not specifying exactly how. So this chapter example, a quality policy should summarize the organization's view on the meaning and importance of quality as it relates to competitiveness, customers, suppliers, employees, and continual improvement. A statement of values and priorities and not a procedural um, work. So for a policy to actually work, it needs to be integrated with strategic plan and deployed through an appropriate initiatives, and performance tracks projects have to be justified and scheduled, and performance has to be measured and reported. Policy should be actionable, and this chapter acknowledges that some situations may call for temporary, adaptation. If the adaptation happens, it must stay within the original intent of the policy, where the policy loses credibility with stakeholders. A well-documented and properly deployed quality policy gives you the three concrete things: a written guide to managerial action that lends stability to the organization, explicit consideration of quality problems and their ramifications before they occur, and a basis of auditing actual practices against the stated policy. And here's the real test whether a policy is working. Um, deployed, a deployed policy should cascade throughout the organization, directly impacting each functional area and indirectly affecting the events, activities, and outcomes that depend on those functions. If a policy is not having the cascading effect, if it's sitting a binder somewhere and nobody's behavior has changed, the chapter is blunt about it. It means the policy is not fulfilling its purpose. So every function and every person impacted by the policy has to align their own objectives and procedures to support. So a quality information system or QIS is defined as a collection of data. Um, Rules and equipment that creates information about quality in a systematic way. It collects, stores, analyzes, and manages quality-related data from customers, suppliers, and internal processes. And it generates information as printed reports, displays, or signals sent to mechanical devices. It's also worth noting that it's not optional in every industry. The chapter of the book specifically points out the FDA requires pharmaceutical companies to maintain a QIS by law. It helps to understand what a system actually means here. It ties several components together that in common with each other. And the system quality engineers care about dynamic and goal oriented. They have inputs, outputs, operating rules, data storage, and boundaries, and they deliberately designed by people, usually cross-functional teams, to achieve a specific goals. It's also worth being precise. An effective organization doesn't have one single QIS. It has a numerous quality systems, some manual, some computerized. Many hybrids of both. On screen are 8 distinct uses the chapter list for QIS, and I'll run through 8 of them. So it can initiate action, for example, a generating shop order automatically from a customer order. So it can control a process directly, like keeping a laser cutting machine operating within specification limits. So it can monitor a process, a real-time production machine interfacing with control charting. It can record critical data like measurement tool, calibration records. It can create and deploy operating procedures such as ISO 9001 based on quality management system itself. It can manage knowledge base, capturing, storing, and retrieving organizational knowledge. It can schedule resource usage like personal assignments, and it can archive data such as historical customer order fulfillment records. The chapter also flags a broader trend worth mentioning here, like the Industry 4.0, the fourth industrial revolution in manufacturing, which is characterized as big data, advanced analytics, human machine interface, and digital physical transfer technologies like 3D printing. So all of which depend heavily on kind of information system structure. So the widespread use of microcomputers and programmable logic controls, or PLC, has completely transformed the modern factory floor. So it's worth understanding both halves of the system. A PLC has built a program and logic that, directly control machines and processes. There's a growing trend toward distributed measurement and control, meaning fewer and fewer technicians are physically turning dials or opening and closing valves. So that work is now handled by the PLC itself. The catch is that many PLC don't have any human interface at all. So um, no monitor, no keyboard, and they widely distributed through the plant. Sometimes hundreds of them. So which makes manual data collection slow you know and programming language itself is not particularly user-friendly. That gap is exactly what gives rise to large-scale SCADA, or supervisor control and data acquisition systems. So the book in example is SAP, Systems, Applications, and Products used across many industries. Its SCADA system interfaces with every PLC on the network and periodically pulse each PLC's memory registers to collect data. So it provides the human interface that individually PLC lack, usually centralized in a control room where the operators can monitor processes, receive alarms, and intervene or issue an override when necessary. So SCADA systems typically include a real-time trend charts and graphic displays on a current equipment status, plus a database for storing data so it can rapidly retrieve later for analysis and report. So there's an important role for quality engineers here specifically. So the chapter argues an information system should be treated exactly like manufacturing system. So from a quality planning standpoint and the you know and the quality engineer should be involved from the very earliest planning stages to make sure user and the system requirements are properly documented. And even applying advanced quality planning disciplines, even though the product in this case is software, rather than a physical part, and even if the customer is just an hourly employee who will use the system to monitor a process, their requirements deserve the same rigor as any external customers. Okay? So designing a large-scale QIS is genuinely risky. The chapter is blunt that the larger these systems get, the more fraught with the risk of failure they become. So two tools are specifically recommended to manage that risk. The first is the Information System Strategy Matrix, developed by Pearlson and Saunders in 2004. It organizes the analysis across four categories: the hardware, the physical components of the systems, the software, the programs, applications, and the utilities. Networking as well. So how the hardware and software components are connected and data, the actual bits of information stored in the system. For each those four categories, the matrix asks the same three questions. What is it exactly? Who uses it and who manages and where does it physically reside? So walking through all 12 cells of that matrix systematically forces a level of planning discipline that the system design usually skips. So the second tool is the V model. Um, Sorry, my nose is really itchy. The V model for software development. It starts on the upper left with high level user requirements and cascades down through a functional specifications and detailed requirements. So getting more specific as you move down to the left side of the V. Um, then on the right side of the V, moving upward, test protocols are developed, executed, and documented to verify that each corresponding design specification was actually met. So software module test protocols verify the detailed design. So the system test protocols and user acceptance verify the functional specs and so on. So all the way up, back conforming against the original user requirements were satisfied. So the quality engineer's job is to be involved through this entire very V model on both sides to ensure quality and data integrity during the execution. So one very practical warning from the chapter is tasks that seem trivial, like naming conventions for sensor PLC, can have a huge downstream impact. So imagine like building a downstream report for a packaging area with hundreds of PLC and thousands of sensors. A good naming conventions lets you capture a whole group of related variables in a single database query using a wildcard. So without one, the user is stuck specifying every single sensor individually. So the same care applies to test protocols themselves. How much data to collect, how often to sample, and whether the sampling window is long enough to actually detect variation caused by the control system, including whether the controller overshoots its target during the recovery from a process upset. So let's close this QIS discussion with a concrete case study from this chapter because it makes everything we've covered feel rather than theoretical. So the setting is highly let's say automated packaging plant in Texas. So before equipment breakdowns plagued the facility for the entire first year of their production, the downtime was so excessive that the plant was actually operating below the break-even point, a genuinely dangerous position for any manufacturing operation to be in. Management's response was to make a major investment in the new information system. So over the following year, nearly every machine in the facility was linked through a network to a central database. Sensors were added to monitor key production processes, and automatic feedback systems were installed and gradually turned until they achieved stability even in the most complex processes. So customized reports were built to distill a genuinely vast amount of data into something usually usable. The system analyzed data from nearly 700 machines and automatically identified the top three concerns in each functional area, printing a single one-page summary at the end of productional shift. So importantly, the quality department and the maintenance department worked together to design that report format. And the general manager personally helped establish the equipment performance standard tied to the balanced scorecard that we discussed earlier. So when performance missed the target, the report highlighted it in the large bold font. So problems could be missed in design choice that is worth calling out specifically. So the team spent months deliberately balancing automatic data collection against human interpretation of that data. So it would have been technically easier to build a fully closed loop automatic control system, but that would remove the human intervention and thoughtful study of what the process data was actually saying. So they chose not to fully automate away humans' judgment. So the results speak for themselves actually. The plant achieved a dramatic improvements in throughout in less than 6 months after the implementation of the QIS. So by the end of the second year, the plant had reached its best in class quality and its profit surpassing 10% from the original performance target. This is really like the entire chapter, like the miniature strategic goals, cascading scorecard, and well-designed quality information system, all working together to turn around a genuinely failing operations. Okay? So let's bring the whole chapter together with the five closing points, and I'll expand verbally. So first, strategy starts with SWOT and ends in an action plan. So everything in between the 10 effectiveness test, SMART goals, the cascade from strategy to goal to objectives to functional objectives exists purely to make sure that the broad aspiration strategy actually turns into something a specific person will do by a specific day. So second, every stakeholder group has a different needs and a policy or strategy has to be audited against all of them: stakeholders, executive, employers, suppliers, and customers, and the community. So ignore any one of these groups, and even technically excellent quality strategy can fail politically or commercially. Third, metric must link to strategy and resist gaming. So a metric that is not tied to the strategic vision is just noise. And a metric that can be gamed, like cutting maintenance spending at the expense of future reliability, will actively work against you unless it's designed defensively. So the way the maintenance productivity example that we mentioned. Fourth is the WBS, the Gantt chart, and the RACI matrices are what actually turn a plan into accountable execution. So without them, you have a strategy document, and with them, you have a specific people doing a specific task on a specific timeline with a clear ownership when something goes wrong. And fifth, a well-built quality information system turns raw a plant data into a genuine rescue plan. Let's say the Texas packaging plant case study is a proof that the right combination of sensors, networking, and thoughtful design reporting can make the operation from break even into the best class in for the next 2 years. So that's the full chapter. So I'm happy to have a deeper or single of these two. Um, the decision tree, math, the RACA chart, or the QIS design tools, if that would help. So I hope you enjoy this lesson and you've got a value for these slides. So I hope I'll see you soon for the next topic. Bye bye.